Fifth lesson, correlation and regression. In this lesson, we have to study about scatter diagram. This used bivariate data. Therefore, two variables. In x-axis, normally we used to independent data for that. In y-axis, we used dependent data. Like this. As example, breaths per minute and pulse rate. In x-axis, one variable, it is independent one. Y-axis, other variable, it is dependent one. Correlations means this linear data, this data, how change x with y, positive or negative, or what is the relationship between independent and dependent data. In this graph, you can see increasing x-axis data, but y-axis data going down, decreasing. Therefore, we call negative correlation. This we can see clearly negative. Therefore, we can introduce of this strong negative correlation. Also, final graph, y values increasing with x-axis, x values clearly. Therefore, we can say strong positive correlation. Correlation means what is the relationship between y and x. Second graph, you can say it has negative correlation, but not cleared one. Therefore, weak negative correlation. Fourth graph, positive correlation. Y value increase with x values, but not cleared. Therefore, we call weak positive correlation. In third graph, we cannot see clear positive or negatives, all mixed together. Therefore, we call no linear correlation. This basic correlation methods you have to know. Strong negative, strong positive, weak negative, weak positive, and no linear correlation like this. An independent variable is one that is set independently of the other variable. It is plotted along x-axis. A dependent variable is one whose values are determined by the value of the independent variable, dependent on x-axis. Therefore, depending on independent variable, it is plotted along y-axis. We can consider example 1. Area A, B, C, D, E, F, G, H, I, J, distance 0.6 like that. Population density means people divided by hectare like this. We can plot this graph using this. Distance from center to x-axis, it is independent variable. We used y-axis as population density like this. Then points are changing like this. This is, we can see it has negative correlation, but problem is not cleared one. Therefore, we call there is a weak negative correlation. First part, draw a scatter diagram like this. Describe the correlation between distance and population density. Intercept your answer to part B. As distance from the center increases, x-axis now, then the independent variable increases, the population decreases. Therefore, dependent variable decreases. That's called B negative correlation because it hasn't clear negative correlation. Linear regression. This is the very important part of this lesson. What is the meaning of linear regression? Like line of best fit. If we have some points in the coordinate axis like this, first one is x1, y1, second one is x2, y2, third one x3, y3, fourth one is x4, y4. It has positive correlation, but not cleared one. Therefore, weak positive correlation. Then we have to plot linear relationship like this line. We have to find this line that called linear regression. If you have some points, we have to draw best fit line. It is called linear regression. For that, we have to use these data x1, y1, x2, y2, x3, y3, and x4, y4 for that purpose. The regression line of y on x is written in the form y equals a plus bx because it is line. Normally, line we can call y equals mx plus c. That means y equals bx plus a. B is gradient, a is intercept. Then we have to find a and b using these basic data x1, y1 to x4, y4. The coefficient b tells you the change in y for each unit in x. If the data are positively correlated, b will be positive. Like this, no? It has positive gradient. If the data are negatively correlated, line to be like this. Therefore, gradient is negative. Therefore, b also negative. This is the basic things you have to know about in linear regression. If you have some points like this, we have to find best fit line that we call linear regression. For that, we assume that line equals y equals a plus bx. B is the gradient. If data are positively correlated, B will be positive. Data are negatively correlated, B will be negative. Okay. We consider example 3 now. There are two variables, W and G. We have details of that. W, x-axis, therefore, we assume it is independent variable. G in y-axis, we assume that is dependent variable. Points like this can mark these points, then we can get this type of relationship. We can assume this is positive correlated. Describe the correlation between daily mean wind speed and daily maximum gust. Okay, it is positive correlation. Also, we can see this clearly positive, therefore strong positive. The equation of the regression line of G and W, G on W for these 15 days is given. G equals 7.23, G is y-axis, W is x-axis. 7.23 means intercept, 1.82 means gradient, gradient is positive, therefore positively correlation. Given interpretation of the value of the gradient of this regression line. Gradient of this line is positive. That means daily maximum gust increase with mean wind speed. Simply, we can say G is increase with W. If the daily mean wind speed increases by 10 knots, the daily maximum gust increases by approximately 18 knots, like this. Okay, we have relationship. 1.82 means if x change 1, y change 1.82. Then x change 10, y will be changed 18.2. That's is like this, approximately 10 to 80. Justify the use of a linear regression line in this instant. What is the use? The correlation suggests that there is a linear relationship between G and W. We can clearly find what is the linear relation in between W and G. That is like this, 10 to 80. If W change 10, G will be changed by 18, like this. There is a relationship between G and W, so a linear regression line is a suitable model. Very easy to understand relationship between these two variables. That's the main use of this. This part is more important than other two. How to calculate least square linear regression. Simply, we can say how to find that best fit line y equals a plus bx. For that, we use sum of the squares of the residuals. This one is same as earlier example. This is best fit line, we call regression line. Basic data x1, y1, x2, y2, like that. Every data has some changes with best fit line. Epsilon 1, epsilon 2, epsilon 3, epsilon 4, like this. If we want to find this regression line, minimize this value, sigma epsilon I square. If it is minimized, we can get best of line. Also say, we can say best fit line. Also, we can say regression line. Equation of the regression line of y on x is, we know that y equals a plus bx. To find A and B, A is intercept, B is gradient. Means y equals mx plus c naught. Then B equals sxy and xxx. Also, we can find A using y bar minus bx bar. That's the main important thing. Do you know about to find this regression line? You have to know about these two clearly. B is sxx over sxy over sxx. After finding these two, you can find A using this one. Y bar means mean of y, x bar means mean of x. What is the mean of sxy? Xxy equals sigma xy minus sigma x into sigma y. If you have two variables like this, x and y, x is independent variable, y is dependent variable like this, 1, 2, 3. Therefore, y values 0, 1, 4, like this. How to find xy? You have to find sigma xy. Xy equals how much? 0, 1 into 0, 2 into 1, 2, 3 into 4, 12. Okay, then you can find sigma x. Sigma x equals sum of the value of x. 1, 2, 3, total is 6. Also, you can find sigma y. 0, 1, 4, total is 5. Also, you can find sigma xy. How? 0 plus 2 plus 12, 14, like this. Then sxy, you can find using this formula. Sigma xy equals to 14 minus sigma x equals 6. Sigma y equals 5. Therefore, 6 multiplied by 5 divided by number of data. Only 3 data. Therefore, 3. Then we can cut these two. 2 into 5, 10. 14 minus 10 equals 4. Therefore, s xy equals 4. Then we have to find this one. For that, we want to know about sigma x square. X square means 1 square, 2 square, 3 square, like that. Then sigma x square, you can find easily 14. Then what is the value? Sigma x square equals 14 minus sigma x equals 6. Then 6 square over n means number of data 3. Therefore, 14 minus 6 square, 36, divided by 3, 12. Therefore, final answer is 2. Then you can find B. What is the meaning of B? B equals x, xy divided by sxx. Like this. Xxy, we already found 4. And sxx equals 2. Therefore, B is 2. Very easy. After finding B equals 2, we can find A using these two. What is the meaning of x bar? X bar equals sigma x over n, average of x. Sigma x 6 over 3, number of data equals 2. Also y bar equals sigma y bar over n. Sigma y over n equals to sigma y5 over 3 equals 1.67. Therefore, A equals y bar 1.67 minus B2 into x bar, how much? 2. Therefore, 1.67 minus 4 equals to minus 2.33. This is the value of A. Then regression line equals to, what is the value of A? We found now minus 2.33 and B is 2 plus 2x. This is the regression line. That's the main thing you have to study about this lesson. Main thing. It is very easy. If you have some data with two variables, x and y, x is independent, y is dependent, you can find basic data like this, sxx and sxy. Sometimes you have to know about syy also, but most cases you have to find only these two. Using these two, you can find p first. After that, you have to find x bar and y bar, mean of x and y. Then you can substitute here to find a. Then you can write regression line like this. Now you can do this example 5. The result from an experiment in which different masses were placed on a spring and the resulting length of the spring measured are shown below. X-axis show masses 20, 40, 60, 80, 100. If 20 kg placed on a spring, length of the spring equals to 48, like this, 48 centimeters. Then x is independent variable, y is dependent variable. Calculate sxx and xxy. Already given sigma x square, x bar, sigma xy, sigma y square, all detail given. Very easy to find sx and xxy. You have to know about this one only. Sxx means sigma x square minus sigma x square over n. Therefore, given data, you have to substitute. Sigma x square means 22,000 minus sigma x 300 square divided by n number of data. You can see only 5. After simplification, 4,000 equals to sxx. Then sxy we can find using this formula. All details given, it is very easy. Then part B, calculate the regression line of y on x. You know about that. B equals sxy over sxx. Then you can find B. Then y bar and x bar given using the B value of B, you can find A. After that, substituting y equals A plus bx, regression formula equals y equals 43.85 plus 0.2305x, like this. Then use your equation to predict the length of string when the applied mass is x is given. You have to find y using derived equation. You have to substitute that values to x, 58. Substitute 58 for x. Very easy. You can find value. 130. You can find value. Using this data, if you can find regression line, very easy to predict new data. It is a good application for using this regression line. Comment on the reliability of your predictions. Assume the model is reasonable to predict when the mass 58 is reliable, since this is within the range of the data. You can see with this data. 58 means in between these two, no? Your answer also 57.3. It is reliable in between these two, or nearby these two. Okay, not exactly, but very near. Also, after substituting 130, answer is 73 something. 130 means out of data. 73 means more than 68. It is reliable. Therefore, this regression method is good for predict data. This is the final topic of this lesson. Product moment correlation coefficient. This also gives some relationship between independent and dependent variables, same as bivariate normal distribution. If PMCC, product moment correlation coefficient, can take values between 1 and -1. 1 is perfect positive linear correlation. -1 is perfect negative linear correlation. Linear correlation, we can find using this formula. R is this product moment correlation coefficient equals to SXY, you know about that, divide by root of SXX into SYY. SX, XX, SYY, also SXY, you can calculate using according to that formulas. All formula given in formula booklet. Also, this one also you have to know about R, correlation coefficient. R equals 1. If R equals 1, positive 1. Perfect positive linear correlation, like this. This is perfect negative correlation, like this. It is equals to -1. This one is always change, X with Y. Therefore, we write R equals 0. R is 0 or close to 0. There is no linear correlation, like this. In this example, describe about that. The number of vehicles, X millions, X axis indicate number of vehicles in millions, and number of accidents, Y thousands, in Y axis. in 15 different countries. Number of data equals to 50. The following summary statistics were calculated and a scatter diagram of a data is given to the right, like this. You can see it has positive gradient, therefore positively correlation. Sigma x given, sigma y, sigma x square, sigma y square, sigma xy, all data given. Calculate the product moment correlation coefficient. Product moment correlation coefficient equals to this much. SXY, SXX, XYY. We have to find. Therefore, step by step, we can find this data. SXX first, then XYY, all basic data given. Also, SXY, like this. After substituting these values, we can find R. It is very close to 1, therefore positively correlated. With reference to your answer to part A and the scatter diagram, comment on the suitability of linear regression model for these data. We can clearly see it is positively correlated. Also, these are very close to 1 means that also positively correlated. For scatter diagram, the data appear to be linearly distributed and the correlation coefficient calculated in part A is close to 1. So a linear regression model appears suitable for these data. Like this, we can find correlation coefficient using same method. Example 10, different than other examples because it is used codings. Normally, you have to find normal values first using DM. This case, all data mixed. Using the formula, you can find SYY and SMM first. Show that, sorry, SYY and show that SMM equals this one. To that, sometimes you have to use these codings because if you want to find SYY, you want to use this formula. But this formula contains sigma y square like that. But you can use this formula because sigma y, we don't know. But using this formula, you can find sigma y. Also, sigma x given. Using that one, you can find sigma y also, like that. You have to find other details using given details. Then you can do like this. According to sigma y square, then we can convert to m over 20. This one also sigma y, m over 20, like this. Then sigma y given, then you can find some relationship between sigma y and, sorry, SYY and SMM. After writing like this, 1 over 400, you can write like this as a factor. Then balance is SMM. Same equation for the SMM. Then SMM you can find using that. Also sigma x equation you can write like this, but sigma x given, but you don't know about sigma d. Using that, you can find sigma d. Using sigma d value, you can find SD. Then you can easily find R value. That's the things you have to study about this lesson.